it can be either one-dimensional projectile motion or two-dimensional. Another application of one-dimensional is when a bullet is fired. Okay, when a bullet is fired, that it is whoever wants to shoot targets whatever, okay, he or she is intended to shoot, and the bullet is fired. So here, the bullet travels horizontally. It travels horizontally for some time. I'll give you a picture simulation of what I'm saying. So he fires the bullet, and then the bullet goes horizontally. Then, okay, then if the target is on the ground, hits, then eventually hits the ground. When a missile is fired in a helicopter or in an airplane, okay, here the target is obviously on the ground. So whoever is firing targets an object or somebody on the ground, and then so the bullets, the direction, or what we call as a trajectory of the bullet, goes horizontal for some time and then bends to the ground. So in one-dimensional projectile motion, the velocity given to the object is horizontal to the ground. Is horizontal to the ground. Please, are we okay? Are we okay? Another situation where one-dimensional projectile motion is applied is, you see, when you find yourself on top of a story building, and then an object is being thrown to somebody, an object is being thrown to somebody a distance away from the building, you apply one-dimensional projectile motion. Here, you see, when you apply vertically downwards motion, it will not get to the destination because let's assume I have this in my hand. When I drop it, it will never get to somebody a distance away from the foot of the building. So the body or the object has to be thrown horizontally so as to get to whoever needs it a distance away. Please, is that clear? So let me give you a diagram of what I'm saying. So in one-dimensional projectile motion, there is the ground. The ground is the reference point. The object is held a distance above the ground. So the object is here. From the object to the ground, there is a certain height, vertical height, h. Okay, so this object being projected to the ground is given an initial velocity. So this is h. There's the height h. The body is given an initial velocity u. U or v. Here we call the initial velocity given to the body as, so u is called velocity of projection. Velocity of projection. Okay, velocity of projection. Now, when the body is given this velocity, this is the path taken by the body. The path taken by the body is such that the body goes, initially will be so horizontal, but as the body journeys on, you realize that its path is bent to the ground. Is bent to the ground and eventually drops on the ground. Okay, so if I have this object in my hand and throw, the object few seconds after throw would go horizontal, but as time goes by, you realize the object burning to the ground, so it drops to the ground. Of course, no object when thrown will remain horizontally or in the air forever. Please, are you following? Are we following?
Yes, please.
The object will never be suspended in the air forever. It will go horizontally for some time and then will be bent to the ground. All right. Now, so this is an example of a projectile motion. Why is this one-dimensional motion? Because the initial velocity given to the body U is horizontal to the ground. It's horizontal to the ground, the initial velocity. Please, are we okay with what qualifies it to be one-dimensional projectile motion? Are we okay?
Yes.
All right. Now, let us try to follow the path of the object. Let's assume at a point in time the object is here. Let me even bend this. So this is the final destination of the body. Let's assume that at a point in time the object is here, and it is at t is equal to 0. The object is over here. At t is equal to 1, t1, the object is now here. At t2, the object is here. At t3, the object is here. And finally, at t4, the object is on the ground. We are trying to follow the path of the object. Class, are we okay?
Yes, please.
We are trying to follow the path of the object. Okay, and the T1, T2, T3, T4 are the times taken to get to this point. It will take a time T2 to come here. It will take a time T3 to come here and finally drop on the ground, right? Now, there is one. We can trace the path of the object by considering, okay, the body initially is here. Now it is here. Okay. From the reference point or from the ground, we look at the body. The body is initially here at t is equal to 0. After t2, if an observer, please, here we are looking at an observer looking at the body from here. So this is the observer's eye. So at t0, the observer sees it to be here. Okay. At time t is equal to 1, the observer sees that the body has been displaced from its original position by this margin. By this margin. So the body after T1 has been displaced from its original position by this margin. And so this becomes the horizontal displacement of the body after T1. So from here to here, this is the horizontal displacement. Okay. And this, then after T2, how is the body displaced horizontally by the observer? We realize that this is the reference position, its initial position. But we see the body being displaced horizontally by this margin. So from the original position horizontally, this is the extent to which the body is displaced horizontally. After T3, how great or large has the body been displaced horizontally from the original horizontal to the new position? This is the horizontal displacement of the body. Then finally, when it drops on the ground, how much is the body displaced horizontally from its initial position? We realize that it is from here to this point, x4. Please, are we okay? Are we okay
Yes, please.
with the horizontal displacement?
Yes, please.
If you have any question, ask.
Yes, please.
If you have any question, ask before I continue. Yes, we could also see a vertical displacement of the body at any new position. A vertical displacement. You see, the whole height from the ground as seen by the observer is h. We also realize that after the body moves from here and gets here, we also see that it is displaced a little bit from its initial position by this amount. A very, very small. Here is very, very small, h1. Per our drawing, we see it as very small. When it comes to this position, we also realize that it seems to be displaced vertically. At T2, we also realize that it seems to be displaced vertically by this amount. So this is H2, which is also the same as from here to this point. When the body is here, we also realize that it is displaced vertically from its original position by this margin. Vertically, and we are calling this as H3. This is the same as from here to there. Now, when it finally drops on the ground, its displacement vertically is the same as the height of the initial position of the body vertically. So when it finally drops on the ground, it is displaced by this amount, h as the height of the object from its initial position. Please, are we okay, or you need further clarification?
So please, can you come again?
Okay, so we are looking at the vertical displacement as the body journeys, okay, through, and we are looking at the horizontal displacement. Okay, when the body comes here, it is displaced by this amount. Please, this amount can also be brought on the ground so that from here to here we have x1. From here to here we have x2. Then from this point to this point, it is displayed by this amount, x3 and to s4. So all that we are doing is that for any new position of the object, we are trying to look at the extent to which the object is displaced horizontally and vertically, okay, as time goes by. Please, are you okay?
Yes.
Are we okay?
Yes, please.
Because of this, it implies that in projectile motion, we have to analyze it horizontally and we have to analyze it vertically, because from what I've just demonstrated, we could see at every time T1, T2, we could see a horizontal displacement and we could see a vertical displacement. Okay, and so in projectile motions, we analyze displacement, velocity, acceleration, horizontally and then vertically. All right. Okay, so let's look at the horizontal displacement first, or horizontal analysis of projectile motion. Horizontal analysis. Then when we finish, we will look at the vertical displacement, the vertical analysis. In the horizontal analysis, don't forget we consider some conditions. The condition is that one, we ignore neglecting air resistance. We have neglected air resistance. Now, the second consideration is that, or condition is that, you see, because we are looking at what happens horizontally. When a body is moving horizontally, effect of gravity is not there. When I'm moving, when I walk, gravity doesn't act on me. Gravity would only, it acts on me, all right, but it will not affect me, okay? It will never affect my speed so long as I'm running or walking horizontally, okay? It is only friction that would affect my speed or velocity as I go horizontally, please, okay? So when a body is moving horizontally, gravity does not affect the body's speed. So we have neglected air resistance. Force of gravity has no effect horizontally. If force of gravity, if air resistance is neglected, gravity has no effect horizontally, then what the deduction we could make is that when a body, the body's velocity horizontally will never change. So the body's initial velocity, u, the body's initial horizontal velocity, u, is equal to the body's final velocity, v. Okay, so and projectile motion, when you are looking at the horizontal analysis, gravity does not change. Gravity, the velocity of the body does not change. Please, are we here?
Yes, please.
And a projectile motion, I'm taking it again. When you are looking at horizontal analysis, the initial speed of the body is equal to the final speed of the body. And what is the reason? The reason is that horizontally, we have neglected air resistance. And then gravity too has no effect horizontally. So it means that the only factors which can reduce the body's speed are neglected or are eliminated. So if you are asked, why is the initial velocity equal to the final velocity? It means that horizontally, gravity is not there and air resistance too has been eliminated. And that is why initial velocity is equal to the final velocity. Please, are we okay?
Yes.
Please, you
All right.
repeat yourself.
Come again.
Please, can you repeat what you said?
Okay. Under projectile motion, when you look at horizontal analysis, okay, initial velocity of the body, u, is equal to the final velocity. What I'm saying is that when the body gets here, so long as we are looking at horizontal analysis, the velocity of the body here horizontally will be equal to the velocity of projection. When it comes here, the horizontal velocity of the body at this point will still be equal to the velocity of projection. When it comes to this point, the horizontal velocity of the body here, okay, of the body here would be equal to the velocity of projection, okay? Because horizontally, we have neglected air resistance and we have gravity too has no effect on the body horizontally. That is why u is equal to v. Okay?
Yes, please. Thank you
Good.
so much.
All right. So if this is it, then we want to understand, okay, in that case, what will be the displacement of the body horizontally with time? Okay, at T1, what will be the equation for determining horizontal displacement x1? At T2, what is the equation for determining the horizontal displacement x2? On and on and on. That's the next thing we are going to look like. So this is the analysis of the velocity. Analysis of the body's velocity horizontally. Horizontally, please. I'm saying horizontally because there is a vertical analysis. There is also a horizontal analysis. So this is the analysis of the body's velocity horizontally, and that is initial velocity of projection u is equal to the final velocity at any time t. Okay, let's look at what will be the expression for the displacement of the body at any time t. What will be the displacement of the body at any time t? Please, I'm coming. Please, what is the formula for velocity in terms of velocity in terms of this displacement and time? What's the formula for determining velocity in terms of displacement and time? Yes. Oh, the feedback is not good. Yes, let me call. Okay. Please, Epia Watman, if your line is good, please contribute. Or anybody, if you are ready, contribute. Yes, Yaba, what is the formula for velocity in terms of displacement and time?
Is velocity is equal to displacement?
Okay.
Yes.
Good. So velocity, please you mute after contribution. Okay. So V is equal to S over T. Our interest is that we want to find the displacement at time T1, T2, the horizontal displacement at time T1, T2, T3, and T4. Because if you make displacement the subject from here, S is equal to V on T. Okay. It means that displacement is equal to velocity times time. Millicent, please mute yourselves for me. Those of you who haven't unmuted, do so for me. Okay. Because displacement is equal to velocity times time, it means if I want this horizontal displacement at time t1, x1 will be equal to, what is the velocity? The horizontal velocity is constant. It's always equal to the velocity of projection. So x1 would be equal to u times the time taken to come here, t1. Millicent, I want x2. Help me. I want the horizontal displacement x2. What do you think will happen? If x1 is equal to u times t1, Millicent, s2 would be equal to, let's try. Please, when I call you, just feel free to contribute. We are learning, so go ahead.
Please, x2 is equal to ut2.
Yes, ut2. What about x3? Yes, anybody? It can be Millicent.
Please, x3 is equal to ut3.
Millicent, why is you repeating in each situation? Why? Why is
Please,
you
please.
repeating?
Sir, please, because displacement is equal to velocity times time, and u is
Mhm.
equal to
And
initial
u-
velocity equal to final.
And so u is what? U is
It's
what?
representing
Constant.
U is
velocity.
constant. Is that okay? Now, I want x4. X4. X4 would be equal to, yes. Oh, let's hurry up. Anybody can try. X4 is equal to
U times T4.
U times T4. Is there any other horizontal displacement? Is there any other horizontal displacement? Yes or no? Good, no. And so it means that S4 is the total horizontal displacement. Total horizontal displacement. And this total horizontal displacement is given a particular name. We said the total horizontal displacement of the body is known as range. So it means x4 is equal to, is what we call as the range. And so the range is the total horizontal displacement of a body in projectile motion. Now, we look at different times at t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3. We realize from our analysis that the total time is what? What is the total time here?
Yes, ma'am. I've been able to join.
We know you are here. What is the total time here? Which letter?
T4.
T4.
Oh.
And so, because T4 is the total time, there is a name given to it, and that is what we call as the time of flight. So here our T4 is given that unique name, time of flight. And so we define the time of flight as the total time taken during the whole journey of a projectile. So the range is the total horizontal distance, okay? And the time of flight is the total time taken. All right. And so from our analysis, if S1 is this, S2 is this, S3 is this, S4 is that, then we can say that the range is equal to, I want somebody to help me. For one-dimensional projectile motion, the range R is equal to, yes, I want
Initial velocity.
Come again.
U times capital.
Initial
Oh,
velocity
so
times the
U
total time.
times. Thank you. So the range is equal to the constant velocity U, velocity of projection U, times the time of flight. But in between, x1 is a horizontal displacement, s2 is it, s3 is it, but s4 is the total horizontal displacement, which we have given a unique name, range. If you have any question, ask before I continue. Abigail, mute yourself. Please, do you have any question before we move on to another aspect. So we have analyzed the velocity. With the velocity horizontally, we realize that it is constant. Initial is equal to the final. And what is the reason? What is the reason for this constant? Adoma, Adoma, what is the reason for the initial velocity being equal to the final velocity horizontally? What's the reason?
Because it's horizontal, and then it's neglecting a resistance, and gravity has no effect on it.
So yes, you are right, but put it this way. U is equal to V because horizontally air resistance, fine. In under projectile motion, air resistance is neglected. And two, horizontally, gravity has no effect on the body. Okay.
Yes,
Bushra,
please.
I want you to help me with something. Bushra, what is acceleration? What is acceleration? Okay, maybe Bushra is still thinking through. Let me get to Adwa Asante.
Yes, please.
Adwa, what is acceleration?
Please, acceleration is the rate of change of velocity with time.
Thank you. The rate of change of velocity with respect to time. Okay. And the change, yes, it's a rate of change of velocity with respect, but the change must be, what should be the nature of the change in velocity with time? What should be the nature of the change?
Constant.
No, I won't. Yes, the velocity must be changing, but how should the changing velocity, okay, be like for acceleration?
Increasing.
Yes. The change in velocity must be an increasing one, because we know if the change is such that it is decreasing with time, it gives us a different thing we refer to as what?
Deceleration.
Exactly. Look at, we've analyzed the velocity. It is constant. We've analyzed the displacement. Okay. And here we could say that the displacement, the horizontal displacement x, is directly proportional to what? Is directly proportional to, I want us to establish a relationship. x1 is equal to u times t1, x2 is equal to u times t2, x3 is equal to u times t3, then the s4 is equal to u times t4. We can say from this that the horizontal displacement is directly proportional with what?
Velocity.
With
Velocity and time.
no.
Yeah.
I will take one. I won't take one. It's directly proportional to
Velocity.
Velocity.
no.
Velocity
Time.
and time.
You are saying
Time.
it's time. It only depends on time because and the statement for because velocity is constant, it doesn't change. So x is directly proportional to t because u doesn't change. Whether you come here, u is the same. Whether you come here, u is the same. Over here, u is the same. By the time you land, you are dropping with that same velocity horizontally. So x is directly proportional to t. Ladies, what do you think Amma, are you there? I have two different Amas. I don't know if the other one is there. Amma Jakuma, I don't know if I'm mentioning the name right. Okay, maybe she's on the way. If velocity is constant, please, how do we analyze the acceleration of the body horizontally? What do you think will be the acceleration of the body horizontally?
0.
Why 0?
Because
Why
there is
0?
no change in velocity.
Exactly. So for acceleration, for analysis of acceleration horizontally is 0 because there's no change in velocity. Please, are we okay?
Yes, please.
So these are the key notes you are to determine. Now you can be given a question. Let me create a question, explain before we move on to the vertical analysis. Can I clean the side?
Yes, please.
A body is projected from a height 20 meters. I'm just creating a question. The velocity of projection is 50 meters per second. So here we are told u is 50 meters per second. The body is positioned 20 meters above the ground. Calculate the displacement of the body. The displacement.
Mr. Dia,
Hello.
please, are we to write the question?
Oh, yes, you can write, but I'm just creating a scenario to explain something, okay?
Okay.
So you can
Thank you.
still write. Which are you there?
Yes, please.
Okay. So calculate the displacement, the horizontal. Let me be specific. Because these things, there is vertical, there's horizontal. So calculate the horizontal displacement of the body after a time t is equal to 1 second. T is equal to 2 seconds. And lastly, t is equal to 3 seconds. Yes. Can you try? Just try for me. Do it. And then when I call you, you tell me. Then we move on, okay? Are we through?
Yes, please.
Okay. So, what did you get for the horizontal displacement after 1 second?
50 meters.
So 50 x2
100
x3 150. Can we determine the range? Can we calculate for the range? Yes or no?
Yes.
Can we determine the range?
Yes.
Yes, please.
How? How do we determine it? Because we cannot, because we don't know the time of flight.
Total time of flight.
We don't know. But we can calculate. We can calculate. And we can do so after looking at the vertical analysis. Is that okay? So yes, the range R is equal to U times T. But for now, because we don't know this, we cannot find the range. So let's look at the vertical analysis. Please, is that okay?
Yes, please.
All right. Those of you who just joined, I think the understanding will not be complete, but today, in fact, forgive me, the network it's rained heavily. The weather is still something. Okay, it's still not clear. That's why the network seems to be disturbing us. So pardon me, okay? When you
Yes,
come
please.
to school, I'll buy tasty chef for all of you.
Hey,
Yeah.
chef.
Jot it down. Jot
Mr.
it down
Chef.
and see.
Please,
Yes, I said so.
I'll come.
I'll just
Please,
buy
where
for
will
you.
you be found?
I'll buy for you and go and report that you are eating tasty chef in school.
As long as I'm eating tasty.
Okay, so let's look at the vertical analysis. In the vertical analysis, we are realizing that when at t is equal to at time t1, the body seems to have been shifted from its original position by this amount. When we trace it here, we've got this small, what looks like small one, h1. H at t2, we saw this shift. At t3, we saw this shift. Now, under projectile motion, at the point of projection, when the body is projected, I'm on top of a story building. Then I try to throw an object to somebody, okay, at the ground, but a little bit of a distance from the foot of the building. If the person is directly at the foot of the building, I won't apply projectile motion. I'll just apply vertical downwards and it will get directly to her. But if the person is at a distance, I have to throw it using projectile motion skills. Is that okay? Because if you don't do that, it won't get to her directly. As at the point of throw, because the direction of throw is so horizontal, we say that the initial horizontal velocity for the horizontal velocity, initial horizontal velocity x. Let's use x for initial horizontal. This is always equal to the velocity of projection u. So if you give the body a velocity of 20 meters per second squared, the initial horizontal velocity will be equal to 20. And this will also be equal to the final horizontal velocity because gravity is not there, air resistance is not there. But what happens to the initial vertical velocity? Uy, initial vertical velocity. Yes, what happens to the initial vertical velocity? What is its magnitude? What is the magnitude of the initial vertical velocity? Yes, can somebody help? I'm waiting on. Okay, 20 meters per second, more views. Initial vertical velocity. Yaba and Co. Oh, Victoria.
Mr. Yeah, please, I feel like it will change because it will be influenced by gravity or something.
You are right, but what is the initial vertical velocity? I'm throwing this thing. Look at this thing in my. I'm throwing it. Because I'm throwing, okay, the direction of throw is purely horizontal. Okay, so we realize that the initial horizontal velocity will be equal to the velocity of projection. What do you think will be the initial vertical velocity?
0.
Why 0, Equia? Why 0? It is 0, but why 0?
Because it was
Mhm.
it was stationary before you moved it.
You see, because a 0, because at the point of throw initially, okay, the velocity was purely horizontal. There was nothing vertical about it. The direction of throw is 100% horizontal. And so the velocity is only focused along the horizontal. Please, class, are you okay? A 0 because at the point of throw, the direction of throw, because it's 100% horizontal for some time, so the velocity has no component vertically because of the direction of throw. So for y, we say this is 0. So when you throw it, look out what is here. When you throw the body, okay, within few seconds, it will go purely horizontal. Then as time goes by, you realize that the body's direction, trajectory will be changing, bending towards the ground. Then it means that because of gravity, the velocity, which was initially 0, okay, is now changing. And please here, what do you think will be the nature of the change? Will it be an increasing one or decreasing one?
Decreasing.
Increasing.
Which is which? I'm hearing increasing, decreasing. Okay, sure. Initially horizontal, but as time goes by, it will be changing because its direction will be bending towards the ground. Will it be increasing or decreasing?
Increasing.
It's
decrease.
decrease, increase. Okay, it's an increasing one because the body now is moving in the direction of gravity. The body now moves in the direction of gravity. When it's moving against gravity, okay, then the velocity will be decreasing. Is that okay? Are you okay?
Yes, please.
All right. Then, if the velocity will be increasing, the height, okay, the vertical height, the vertical displacement as time goes by would also be increasing. What will be the equation for this increasing velocity? What is the equation for this increasing height? That is with time, as time changes, T1, T2, T3. That is what we are going to look at. So we are going to look at what happens to the velocity of the body, what happens to the displacement, an expression for the displacement, and finally we look at the acceleration as we did for the horizontal analysis. Is that okay? All right.
Yes,
And
please.
here we do that using the equations of using the equations of motion. The first one, V is equal to U plus yes
A
Come again, plus.
AT.
Here we will not use A, we'll use G because the
G.
body falls under the influence of gravity. And will it be plus or minus? Will it be plus or minus?
Minus. A plus.
Why? Why plus?
Because it's not going against gravity.
And so it means that the acceleration, the body would accelerate. That is why it's a plus. The body accelerates due to gravity. If the body decelerates due to gravity, then there is a minus. All right?
Yes, please.
See? All right. Yes. So if the body is here, because of gravity, its velocity will be changing. I want to determine the velocity of the body here. The vertical velocity of the body here. Please, horizontally, we are saying that the velocity is constant. But vertically, the body changes because here you can't eliminate gravity. Though we have eliminated air resistance, okay, from vertical and then horizontal. But for gravity, you can't eliminate it. Okay, and because of that, the speed as the body journeys on and on will be changing, right? So if I'm looking for the velocity of the body here, V1, this is equal to U initial vertical velocity. And fortunately for me, this is 0. Ui is 0. Plus J times the time taken to come here, T1. When the body comes here, and I'm told to calculate for the velocity here, V2. Initial vertical velocity is 0. So the velocity of the body here is G times T2. By the time the body drops on the ground, because when it drops on the ground, the velocity is 0. The body is not moving, so its velocity is 0. By the time the body drops on the ground, the final velocity, we call this as the velocity of impact. The final velocity here, let's use V4, is equal to G times, what do you think will be the time? What will be the time here? T4, which is the time of light, isn't it?
Yes, please.
So generally, we can say that when the body is dropping, it's because its velocity, the body would accelerate when dropping. Its velocity at any time is equal to G times the maximum, or let me point this probably, velocity of impact. V of impact is given by G times T. Or, okay, so sorry, we can't say this is the velocity of impact because there is another velocity which I will tell you, but for anything vertical, V, the velocity vertically, V is equal to G times T. The only thing is that the vertical velocity just before the body hits on the ground will be equal to V times the time of flight. So this is how to analyze the velocity of the body as it drops. Let's also look for an expression for that vertical displacement with time, h. Before that, if you have any question, ask.
Mr. Edia, please, how do you calculate for the velocity just before the object hits the ground?
You see, here, the velocity just before the body hits the ground, okay? You have to be specific. You can't say the velocity. The vertical velocity just before the body hits the ground. Because, and I'm telling you this because at every point, don't forget the horizontal velocity is constant. Okay, so when it's here, there's a horizontal velocity. When it's here, there's the same value of horizontal velocity equal to when it was here, on and on. So the vertical velocity just before the body hits the ground. Are you okay? That is why, Epi, are you okay?
Yes, please.
That is why I didn't even talk about the velocity of impact. We'll get there. When I bring that in, it will confuse you. So we'll get there. So let's look at the vertical displacement. We are looking for an equation for H1 because we've determined an equation for V1, V2, V3, and so on and so forth. If I'm looking for H1, H2, H3, how do I get that? Please, this thing will be clearer when we start solving questions. So you just follow me and don't panic. Okay, let's go through it. When we start solving questions, you realize that, oh, okay, then Ms. Adria was doing a lot to help us understand, but it's not difficult. Okay. So I want to have a formula for determining H1, H2, H3, and then the maximum height when it finally drops. How do I get that? Using this equation. I want you to help me put down the second equation of vertical downwards motion. The second equation.
S is equal to UT
S is equal to UT
plus half AT squared, GT squared.
Okay. Here, because we are looking at the vertical displacement and we are represented by the letter H, we'll clear S and use H. So it means that whenever I'm to determine vertical, it is H. Now H is equal to U, UT. U is the initial vertical velocity. Initial vertical velocity, UY. And here it is 0, isn't it? So
yes, please.
Because this is 0, H becomes half JT squared. All right. Now, it means that if I'm looking for this vertical displacement, appear.
Mr. Edia, please, can the H also be equal to V squared over 2G?
We'll come there. Yes, but I'll talk about that too, okay? So if I'm looking for H1, it means H1 will be equal to half J times the time taken to come here, T1. And that will give me the vertical displacement when the body gets to this point. Class, are we fine? Are we okay?
Yes, please.
Please, if you don't understand, don't let me go. Don't let me go, okay? Ask questions.
Please
Go back.
What I'm saying is that we are looking for this vertical displacement of the body as it drops to the floor or the ground. Okay. So how do we do that? We can determine that using the equation H is equal to ut plus half gt squared, or as Epia said, we can also use this. U squared, V squared is equal to U squared plus 2JH, which I'll explain. So you let me clear this. So if we are using this to find the vertical displacement at any time, then if I want this vertical height covered, H1 would be equal to U. U is 0. The initial vertical velocity is 0 because of the direction of throw. So when you substitute 0 here, you have half JT1 squared. Okay, are you okay? Which are you okay?
Yes.
Adwa, are you okay? And everybody, I wish I can mention all names. Now, I want H2. I want the vertical height at this point. How do I calculate for it? I want this vertical height H2 covered. How do I calculate for it? Bushra, try. Okay, as Bushra is engaging her brain and then, okay, processing, let's have somebody else contributing. How do we get H2? Oh, time.
How G
Half G times T2.
squared.
Good. And so on. And meaning, if I want the total vertical displacement, which is equal to the height, the initial vertical position of the body from the ground, this H here, okay, this H is equal to the same height, the initial position. Then that H must be equal to half J times T4. And what name did we give to T4?
Time of flight.
So it means that the maximum vertical displacement H is equal to half J times the square of the time of flight.
Mr. Edia,
Hello.
please, why don't you make the H a capital H?
The H. Oh, it's because I left. Okay, I cleared the capital H and used small h. But it's just a letter. It can be capital H. So long as I'm saying that this is capital H, and so this will also be capital H. Are you okay? Are we okay? So it means that the vertical displacement H, the vertical displacement H with time is directly proportional to what? Is directly proportional to
Time.
I won't mind. Is directly proportional to
Velocity.
no, open your eyes.
Gravity and time.
No, it's I won't buy gravity. is directly proportional to the square of time. Instead of time of flight, let me use t. Please, are we okay? Because gravity is constant, and then this value, the half is also constant. Please, class, are we okay? Hello, are we fine? All right.
Yes, please.
Acquire your observation. You suggested, can we also use v squared is equal to u squared plus 2jh? Yes. Okay. And here, okay, this will go for the velocity. Don't forget, in determining the velocity at any time, we started by using v is equal to u plus jt, and so this second formula will go for this. And so here we deduce that the velocity is directly proportional to time, because v1 we saw is equal to j times t1, v2 j times t2, and so v is directly proportional to time. We can also use this equation to determine the velocity, and that is, if we are using this, v will be equal to u is 0 here. So this v will be equal to the square root of 2jh1. So if we are 2gh, so if we are looking for the velocity of the body here, and we know the vertical displacement, v1 would also be equal to square root of 2jh1. v2 will be equal to square root of 2jh2, and so on and so forth. Please, are we fine?
Please, could you go over like the last 5 minutes? I want to do something.
Okay, so we earlier determined expression for the velocity here, velocity here. Okay. And we could do the same thing. We use the equation 1. We use the equation 1. V is equal to u plus dt. And then we realize that the velocity of the body at different times can be determined by when you want the velocity here, v1, this u is 0, so j times t1. If I want what is here, v2 is j times t2, v3 j times t3. Therefore, the velocity just before it hits the floor is equal to j times the time of flight. Okay. Now, Epia also drew my attention to the other equation, v squared is equal to u squared plus 2jh. Yes, we can also use this to find expression for the velocity, this same velocity, and it will give us the same answer. And here, because u is 0, v will be equal to square root of, don't forget, let me be systematic. This is v squared is equal to 2jh. So if I want the velocity here, then v1 will be equal to the square root of 2jh1. v2 will be equal to square root of 2jh2. Okay. Therefore, v, just before it hits on the floor, will be equal to the square root of 2jh. Are we okay? Are we okay? So,
Yes.
using either this or this would give us the same results. We realize that this formula is in terms of the vertical height, displacement, h. This one is in terms of the time taken. They should all give you the same value. Please, are we okay?
Mhm.
One last observation. You see, it takes, can I clear this side? The body takes the same time to cover a vertical displacement and then a horizontal displacement. You may not understand. This is what I mean. When the body is here, the vertical displacement is h1. The horizontal displacement is x1. Okay, h1 for vertical displacement and x1 for horizontal displacement. The time taken to cover x1 and h1 is t1. They are all equal to t1. When the body is here, the vertical displacement is h2. The horizontal displacement is x2. The time for this horizontal displacement and vertical displacement is equal to t2. We can say the same thing for h3. h3 and then the horizontal displacement x3. They all go, okay, let me use comma rather. Okay, they all go with the time t3. Meaning, when the body just drops on the ground, okay, vertically it is displaced by h. Horizontally it is displaced by r, isn't it? The range. And what is the time taken to make this vertical displacement and horizontal displacement? Yes. What's the time?
Time of flight.
That's the time of flight. So, yes. So, the body takes the same time to cover a vertical displacement and then a horizontal displacement. If I'm looking for x1, x1 is u times t1. If I'm looking for h1, h1 is equal to half jt1. What I'm saying is that the time over here and the time over here, so long as it's about x1 and h1 are the same. Please, are we okay?
Yes.
So the body takes the same time to cover a vertical, to make a horizontal displacement and then a vertical displacement. Now back to the question I gave you. I was saying that we cannot find the range because we didn't know the time of flight. But the question gave us h, this h, isn't it? Isn't it? And what's the value of h given? What's the value of h given in the question?
20 meters.
20 meters.
And the velocity of projection is 50. U is 50, right?
Yes, please.
Good. We can use this equation to find the time of flight so that we can find the range. Start work. Start work. Engage your brain and then make me proud here. Because we've gone through the vertical analysis, we can use that to find the time of flight. So we can later find the range, okay? Okay.
Yes.
Yes. Mr. Dia, please repeat the question.
The question is that we are looking for the range, which is UT. I've just told you that the time taken to make a vertical displacement and the horizontal displacement the same. Okay, so once I've given you the maximum vertical displacement, big H, it means you can use this to find the time of flight because you have this. J is constant. J use 10 meters per second squared. Use that to find the time of flight. And when you have found the time of flight, you can find the range. All right. If you are to share with us whatever you got from the range, yes. Share with us what you had for the range. Bushra, are you working?
Yes, please.
Okay. Akuya Adoma.
Sorry, I had 100.
100 Ghana cedi. Akuya 100 what?
Yeah.
No,
Is
the
there- I
range.
don't know.
The range is a total horizontal distance, so it's a distance.
Okay, 100 meters.
That's all. Who else got 100? Or if you got anything different, you can share with us. Go ahead. Go ahead then. Please go ahead, share with us. Oh, meaning you didn't get anything different. Okay, so let's see. Let's see. So we know H, that's H to be equal to half JT squared. H is 20. Half by 10 by T squared. Okay. Hey, let's see. Okay. So this and this cancels out. We have T squared is equal to 4. Therefore, T is equal to root of 4, which is 2 seconds, isn't it? Oh, okay. Okay, you are right. Then because U is 50, we have 50 times 2. And this is 100 meters. Okay, so it takes the same time to cover a horizontal distance or displacement and then a vertical displacement. Now, in the books, you see, you'll be told that projectile motion has a parabolic path or trajectory. I don't know if somebody has ever read around that before. If you've heard that before, let me see you. Raise your hand. That he said in projectile motion, it has a parabolic path or trajectory. Has any one of you read around that before?
Yes, please.
Okay. This is what they mean. The equation for the range R is equal to UT. The equation for the maximum vertical displacement is half JT squared. If we make 1 the subject, T the subject, from this is 1 and 2, and substitute it into we are substituting equation 1 into 2. We'll have T is equal to R on U, isn't it?
Yeah.
So let's substitute this into equation 2. You have H is equal to half J R over U squared. When we play around this, we have half U squared J R squared, or half or J over 2 U squared. Now, because you see range is X along the X axis, H along the Y axis, we are saying that let H be Y, vertical. Then let R be X. So the equation becomes half 2U squared JX squared. Now, when you plot, this is what we have, half 2U squared JX squared. J is constant. U is constant. Okay, or U will be given. J is constant. U is the velocity of projection. So if you are given values of X displacement and you plot on a graph, like your linear graph, whenever you are given Y is equal to mx plus c, the dependent variable is Y, the independent variable is X. When you plot, substitute X values into it, you have Y values. When you plot it on a graph, this is the shape you have. This is the shape you have. This shape. And this shape is what we call as parabola. Parabola. And so we said that a body in projectile motion has a parabolic path or trajectory. The trajectory is the path. So it either has a parabolic trajectory or path. So this shape is what we call as the parabolic shape. And this is the equation of the shape. This is the equation of the shape. Half J over U squared times L squared is the equation of this, okay, graph. Just as when I give equation of a straight line, the equation of a straight line is this. Y-axis, X-axis. If it's because it's a straight line, it is this. So the equation of this is Y is equal to mx. This is like this. Y is equal to mx plus c. Okay, where c is the intercept on the vertical axis. So this graph this is a linear graph. This is its equation. Over here too, this is a parabolic graph. This is its equation. Hence, he said a body in a projectile motion has a parabolic path or trajectory. So if you heard it, this is the origin, of it. Is that okay? Is that okay, class?
Yes, please.
Yes, please.
Tomorrow, we'll look at two-dimensional projectile motion. And you realize that it also has its own equation. It also has its own shape. Okay, Oresi?
So please, I'm trying to copy what's on the board, but I think because of the way you positioned the camera, it's blocking what is underneath
Which part? Which part are you writing?
the down part.
Okay. Is it better?
Yes, thank you very much.
Okay. I'll send you a question after the class to play around, okay? To see if whatever we learned today is deep, has gone to your subconscious memory. Okay. Then, so this is a theory, and it is the same theory you'll be applying in solving questions. Okay. All right. So I'll send you the questions. It's exactly 3 o'clock from my watch. This is where I draw the curtains on our meeting. Thanks for, gracing our maiden edition of August Omega online classes. Please tell your other colleagues that we have started. We have started, and so they should come on board. Until we meet again, same time tomorrow. Bye-bye. Take care of yourself. Your work set would follow, okay, on the platform. Right?
Please.
Okay.
Bye.
Bye-bye to all of you.
Bye.
Yes, bye. Those of you writing, please, are you done?
Yes, please.
Okay. Okay. All right. Can I close the meeting, or I should wait for a while? Can I close, or